Well, hello, this is Mrs. Robertson, and today we are going to do lesson 2 from chapter 9, and we're going to talk about theoretical and experimental probability. Have you by chance talked about this in science yet? The different types of probability in science? Okay, just curious. When you do theoretical probability, this is where you are thinking. You are thinking about it. I think this is what's going to happen. That's what you do for theoretical probability. Experimental probability is when you actually are doing it. When you do it, when you do the experiment, that's experimental probability. When you think about what theoretically, should it happen, that's the theoretical. So sort of think of theoretical as thinking, experimental is the doing. All right. Carnival Games. The prize wheels for a carnival game are shown. You receive a less expensive prize if you spin and win on wheel A. You receive a more expensive prize if you spin and win on wheel B. Okay, so we look at those wheels. It says, in a uniform probability model, each outcome has an equal probability of happening. That's a uniform. That means they all have the same probability of winning or losing. You have two ways to win and they're both the same size. You have two ways to lose. They're both the same size. You got that? Okay. Now, this one is not uniform, is it? No. Losing takes up more area than winning. When we're going to talk about these questions. It says, which wheel has uniform probability class? Which wheel is it? A. In number 2, use a paper clip and the tip of your pencil to spin each wheel. We're not going to take time to do that and record the results because we just don't have enough time in our short class period. It says, why do you think winners on wheel A receive a less expensive prize than winners on wheel B? Yes.
Because since there's more probability of winning, it's going to be less expensive.
A less expensive prize because they aren't going to have as many winners on this wheel, are they? So since they don't have as many winners, they can do a more expensive prize. They're probably going to make more money with people choosing that one. Okay, let's go on to the next page, 722. Turn the page. Experimental and theoretical probability. It says, theoretical probability is based on uniform probability. What should happen when conducting a probability experiment? Experimental probability is based on relative frequency, what actually occurs. Okay, that's what I said at the beginning of the lesson. Theoretical is thinking, experimental is doing. It says the theoretical probability and the experimental probability of an event may or may not be the same. As the number of attempts increases, the theoretical probability and the experimental probability should become closer in value. All right, trials. What does the word trial mean? A trial is one experiment in a series of successive experiments. So if you were flipping a coin, one flip would be considered a trial. If you did it 50 times, you would have 50 trials if you flipped your coin 50 times, okay? Now, let's look at example number 1. The graph shows the result of an experiment in which a spinner with 3 equal sections is spun 60 times. Find the experimental probability of spinning red for this experiment. Okay, now, let's listen carefully so you know the difference between experimental and theoretical. It says, the graph indicates that the spinner landed on red 24 times, blue 15, and green 21. In this experiment, what was the probability of red? Well, it's 24 over 60 because when you add those 3 together, you get 60. 24 over 60 or 2/5. The experimental probability of spinning red is 2/5. Now, that's the experimental. What would be that's number 2. Compare the experimental probability you found in example 1 to its theoretical probability? Well, the spinner has 3 equal sections, red, blue, and green. So the theoretical probability of spinning red is 1 out of 3. Since 2/5 is the wiggly room, doesn't mean it's exact, but it's close to 1/3. The experimental probability is close to the theoretical probability. So do you see the difference? Theoretical, it should have been 1/3, but when they did the experiment, it didn't come out to 1/3, it came out to 2/5, okay? Any questions? All right, letter A. Refer to example 1. If the spinner was spun 3 more times and landed on green each time, find the experimental probability of spinning green for this experiment. So go ahead, I want you to do A and B, and then we will go over the answers that you get. Okay, so for letter A, you should have 24 over 63. How did I get 24 over 63? Well, the green was 21. But if we spin it 3 more times and it lands on green all 3 of the times, 21 plus 3 is 24. Now, since I spun it 3 more times, I can't put it over 60. You have to put it over 63. Then simplify it. What will divide a 24 and a 63? 3 does. 3 will. 3 divides 24 8 times. And 3 will divide 63 21. And that's how I have 8 over 21. They do want you to simplify your fractions, kids, when you do these problems. They don't even say it. You're just supposed to know you're to simplify your fractions. In B, compare the experimental probability you found in exercise A to the theoretical probability. All right. Well, the theoretical probability that we had was 1/3. Okay, even if you did it 1/3, it says the experimental probability is close to the theoretical probability, since 8 over 21 is close to what we said earlier of 1/3. Okay, now let's go on to page 723. Example number 3. 2 number cubes are rolled together 20 times. A sum of 9 is rolled 8 times. What is the experimental probability of rolling a sum of 9? Experiment. So this was the experiment. It is, so it was rolled 8 times. So 8 over 20, which simplifies to 2/5. Any questions on how you get the experimental probability? The experimental probability of rolling a sum of 9 is 8 over 20, which simplifies to 2/5. Any questions on that? Okay, let's look at number 4. Compare the experimental probability you found in example 3 to its theoretical probability. Now, if the probabilities are not close, explain a possible reason for the discrepancy. Okay, when rolling 2 number cubes, there are 36 possible outcomes. The theoretical probability of rolling a sum of 9 is 4 over 36, or 1/9. Okay, these are the possible ways you can get a 9. 3 plus 6, 4 plus 5, 5 plus 4, 6 plus 3. There are only 4 ways that you could get a 9. Since 1/9 is not close to 2/5, the experimental probability is not close to the theoretical probability. One possible explanation is that there were not enough trials. And that's a common reason that you will use if they ask you, what can you do to improve to make it closer to what the theoretical probability is? Do it more times. There were not enough trials. So you just do more trials, and then the more trials you do, the closer it should get to theoretical probability. Once again, should. It doesn't always turn out that way. Okay, now I want you to do C, D, and E, and then I will give you the answers to them in just a moment. So go ahead and do C, D, and E. Okay, in these problems, there's a little bit of wiggle room, which we don't like wiggle room in math. We like for it to be exact. In letter C, Earlier we stated that the probability of 1/9 is close to 2/5. So the probability of not getting a sum of 9 would be 3/5. That one's pretty easy, right? Because an event plus its complement has to equal 1, right? 2/5 plus 3/5 is 5/5. So that one's pretty easy. Now the next one, I could see where that one was a little confusing. 2 coins are tossed 10 times. Both coins land on heads 6 times. Compare the experimental probability to the theoretical probability. All right, so 6 out of 10 simplifies to 3/5. The theoretical probability would be 1/4 of the times. 2 coins are tossed 10 times. Compare the experimental probability to the theoretical probability. Theoretically, it would have only happened 1 out of 4 times where both coins end up with heads, where you would have heads and heads. There are 4 outcomes on this, okay? Just so that you understand, when you have 2 coins, you could have heads, 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 tails, 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 heads. So do you see how I got the 4 outcomes with tossing 2 coins? So how many of them are heads, heads? Just 1 out of the 4. So that's how I got the theoretical is 1 out of 4. Do you see that? So it's not that close, 1/4 and 3/5, because that's more than a half. It's more than doubled 1/4. So what do you do to get it closer? You need more trials. Okay, doesn't that make sense? In letter E, it says, suppose 3 coins are tossed 10 times. All 3 coins land on heads 1 time. Compare the experimental probability to the theoretical probability. If the probabilities are not close, explain a possible reason. Well, if you are tossing 3 coins, you have how many possible outcomes? Well, you can have heads, 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 tails. Then you could have heads, tails, heads, right? Now, you could have, I think I've got those all covered. Now you could start off with tails, 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 head, tails, 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 heads. Okay? Then you could have, let's see, I have a possible of 6. Is there one that I've missed on these? Okay, as we look at these, heads, I think we've got them all, don't we? All right, so suppose 3 coins are tossed 10 times. All 3 coins land on heads 1 time. Compare the experimental probability to the theoretical probability. Well, there should be 2 more outcomes because it should be 1/8. So I'm missing 2 outcomes. Which outcomes am I missing? Tails, heads, heads. I don't have that one. And I don't have heads, tails, tails, do I? Those are the 2 I was missing. Now, there it is. 1/8 is the experimental. They did it 1 out of 10. It's pretty close when you think of that. So that's why it is. It's always hard to make sure we get all of our possibilities. Yes, question. Yes, I think I have both of my passes back. Now let's go on to page 724. Example number 5. Predict future events. Theoretical and experimental probability can be used to make predictions about future events. Number 5. Oh, here it says solving proportions. You all know how to do this. The cross products of any proportions are equal, and you know that, don't you, kids? Yeah. Last year, a DVD store sold 670 action DVDs, 580 comedy, 450 drama, 300 horror. A media buyer expects to sell 5,000 DVDs this year. Based on these results, how many comedy DVDs should she sell? Well, you're going to put, it says 2,000 DVDs were sold and 580 are comedy. So the probability are 580 over 2,000, and they simplified it to 29 over 100. So 29 over 100 equals how many should they get if they are going to buy 5,000 DVDs? So then you get that, you do your cross products, divide, and you get 1,450. Any questions on that? Okay, so let's go on and do our guided practice, and then I'll give you your homework assignment. In problem number 1, a coin is tossed 50 times and it lands on heads 28 times. Find the experimental probability and the theoretical probability of the coin landing on heads. Well, the experimental probability equals 28 over 50, but we have to simplify that. What will 28 over 50 simplify to? Yes. 14 over 25. Very nice.
And we'll go in further since we can't.
Right.
Divide 25 by 2.
Yes. Now, does it say we have to write it as a percent? If you did 14 divided by 25 is 56%. If they asked for a percent, you all know how to do that, right? Okay, or hey, you just take it times 4 because 25 times 4 is 100. Now, our theoretical probability, that one is pretty easy. It should be what? 1/2, which equals 50%. We can tell 56 is 6 more than 50%. Okay, any questions on that? I think writing that down would be enough. Number 2, yesterday, 50 bakery customers bought muffins, and 11 of those customers bought banana muffins. If 100 customers buy muffins tomorrow, how many would you expect to buy a banana muffin? 50 customers bought muffins, and 11 bought banana. So I'm going to have banana over customers, okay? And we had 50 customers, and out of 50 we had 11 bananas, right? You all know how to set this up. 100 goes with customers. This is our missing amount, right? How many banana muffins are you expecting to sell if you have 100 customers? Yes, 22. 22. What's the question? How many would you expect to buy? How many people? 22 people. Any questions on that? You could also say, well, 50 times 2 is 100, 11 times 2 is 22. All right, now let's look at what I want you to do for your homework tonight. On page 725, let's do 1 to 3. On page 725, 1 to 3. Then on page 724, you have to do number 5. Yeah, the house problems you have to, or 726, excuse me. 726, you have to do number 5. And then on page 727, these are not that hard to do. They've already done number 9. Do 10, 11, and 12. And that will be all. It doesn't take that long to do these problems, so let's get busy and work on the problems, and then we will go over those again tomorrow. Have a good day.